New Mexico, July 16, 1945, the dawn of the atomic age, the detonation of the first atomic bomb in history. From this beginning came the weapons that devastated the Japanese cities of Hiroshima and Nagasaki. From this beginning has come the vast atomic weapons program of the United States. No man can know every complex detail of the program today, but to work intelligently with atomic weapons, at least, the basic knowledge of the overall operation and what has been accomplished is essential.
The development, use, and control of atomic energy shall be directed so as to make the maximum contribution to the general welfare, subject at all times to the paramount objective of making the maximum contribution to the common defense and security. And the development, use, and control of atomic energy shall be directed so as to promote world peace, improve the general welfare, increase the standard of living, and strengthen free competition in private enterprise. Thus reads the Declaration of Policy of Public Law 703, more commonly known as the Atomic Energy Act of 1954.
Originally created by the Atomic Energy Act of 1946, the Atomic Energy Commission, in the space of a few years, has grown into a many-faceted organization for atomic energy. Established as a civilian agency directly under the President of the United States, the AEC was formulated to control the production, ownership, and use of all fissionable material and provide for research and development in the field of atomic energy. The AEC has continued and expanded the work started in 1942 by the Manhattan Engineer District. By taking over such wartime atomic energy facilities as Oak Ridge, Tennessee, where the scarce uranium isotope U-235 is separated from refined natural uranium by the gaseous diffusion process. The Hanford, Washington Active Material Production Plant, where uranium-238, the most abundant isotope in natural uranium, is converted into a completely new fissionable element known as plutonium-239. The Los Alamos Scientific Laboratory in New Mexico, where the know-how to use this active material is developed and where our wartime weapons were fabricated, and many other lesser-known but still vitally important facilities. Practically all of the production and research work at the Atomic Energy Commission is performed by industrial and commercial operating contractors and private and public institutions under contract to the Commission. Under the direction and overall supervision of the General Manager, the policies and programs formulated by the AEC's 5 commissioners are implemented by the Commission's various divisions. The Division of Raw Materials develops and directs programs concerned with the discovery and exploitation of sources of fissionable material, both within and outside the continental limits of the United States. The Division of Research develops and supervises programs of research in or involving the physical sciences, including new equipment, new methods of instrumentation, and also in the dissemination of technical information. The Division of Production develops and directs the production of active material and manages related AEC installations and community activities. The Division of Biology and Medicine develops and supervises programs related to biology, medicine, biophysics, and is active in the program of making radioactive material available to medical science. The Division of Reactor Development develops and directs the use of atomic energy as the source of power, including the development of related equipment. Very important from the military standpoint is the Division of Military Application. To understand more fully the function of the Division of Military Application, it is essential to know something about the relationship between our atomic weapons program and the atomic energy program as a whole. As set forth in the Atomic Energy Act of 1954, our atomic program is directly under the President, with both the Atomic Energy Commission and the Department of Defense being responsible to him. Congress, through a joint committee on atomic energy, consisting of 9 senators and 9 representatives, is kept informed of all activities of the AEC. Resolutions, bills, and all matters in Congress relating to the AEC or the development, use, or control of atomic energy are referred to this joint committee. A general advisory committee made up of 9 civilians, usually leaders in a scientific or technical field, meet periodically to act in an advisory capacity to the AEC for the purpose of enlarging the panel of talent and experience from which the Atomic Energy Commission can draw on in performing its varied and complete duty. Within the Department of Defense, the Director of Defense, Research, and Engineering acts as principal advisor to the Secretary of Defense on scientific and technical matters, and supervises all research and engineering activities of the DoD. To assist him in this function, he has 2 subordinate agencies: the Technical Advisory Panel on Atomic Energy, which is composed of leading civilian scientists in the field, and the Coordinating Committee on Atomic Energy, which is composed of military members of the 3 services. The Military Liaison Committee, reflecting the military requirements of the Department of Defense, consults and advises the AEC on all matters related to the military application of atomic energy, including the development, manufacture, use, and storage of atomic weapons. The chairman of the Military Liaison Committee also occupies the position of Assistant to the Secretary of Defense for Atomic Energy. In this latter capacity, he provides the Secretary of Defense and principal members of his staff advice and assistance on atomic energy aspects of the Department of Defense policies, plans, and programs. Under the AEC, the Division of Military Application directs the research, development, production, testing, and storage of atomic weapons, manages related AEC installations and communities, and assists in maintaining liaison between the Atomic Energy Commission and the Department of Defense. These groups and committees are the high-level planners and arbitrators who ensure that the 2 separate agencies, the AEC and Department of Defense, work in complete coordination. Functioning under the Division of Military Application, the Albuquerque Operations Office, located in Albuquerque, New Mexico, is responsible for the research, development, testing, production, and storage of atomic weapons, and is vested with the power to make purchases and to let contracts. Through its several field offices, it administers related engineering, construction, and community program, and supervises the work of the private concern who operates under contract various installations on and equipped by the AEC for weapon research and production. The Sandia Corporation, the Los Alamos Scientific Laboratory, and the Lawrence Radiation Laboratory are principal installations doing research and development work. The Sandia Corporation, concentrating on ballistic shapes, electronics, hardware, and handling equipment. Los Alamos, the proving and testing of the high explosive components and the use of active materials in the weapon. Research and the use of active material is also conducted at the Lawrence Radiation Laboratory at Livermore, California, and is administered by the San Francisco Operations Office. When a new weapon is being developed and accepted for production as a stockpile model, work begins at the production installation. For example, the Bendix Aviation Corporation operates the Kansas City plant, and through their subcontractors, produce ballistic cases, electronic equipment, and hardware for weapons. Mason and Hanger, Silas Mason Company, operate the Pantex plant in Amarillo, Texas, to produce high explosive components. And in Rocky Flats, Colorado, the nuclear capsule components produced by the AEC's active material production plants are checked and assembled under a contract with the Dow Chemical Company. With the production of the components and the necessary phases of assembly, the weapon is stored in a stockpile ready for the time when it will be needed. Concurrently, within the Department of Defense, the Army, Navy, and Air Force have been preparing for their participation in the atomic weapons program through their individual organizations and the Defense Atomic Support Agency. All 3 services participate directly in the atomic program. The Ordnance Corps performs development and production functions for the Army and is currently responsible for such projects as non-nuclear components of Army atomic artillery projectiles and fuses for atomic warheads and Army missiles. The details of design and production are accomplished by Picatinny Arsenal. The Bureau of Ordnance, now called Bureau of Weapons, performs similar functions for the Navy. The supporting agencies of the Bureau of Weapons are the Applied Physics Laboratory, Naval Ordnance Laboratory, and the Naval Ordnance Test Station. The Atomic Technical Center for the Air Force is the Air Force Special Weapons Center at Kirtland Air Force Base under the Air Research and Development Command. The mission of the Special Weapons Center includes the responsibility for ensuring weapon compatibility to delivery vehicles and providing drop test assistance to the Atomic Energy Commission. Also, located at Kirtland Air Force Base, the Naval Air Special Weapons Facility performs the same two functions for the Navy. The Defense Atomic Support Agency has its headquarters in Washington and the Field Command located at Sandia Base, Albuquerque, New Mexico. The Chief, DESA, reports to the Secretary of Defense through the Joint Chiefs of Staff. In fulfilling its mission, DESA assists the Office of the Secretary of Defense and the Joint Chiefs of Staff, the military departments and services, and the unified and specified commands by providing technical, logistic, and training advice and services in the field of atomic weapons. It also supervises Department of Defense atomic weapons test activities. In providing technical services, the DESA provides up-to-date technical information on all weapons and test and handling equipment. Chief DESA is charged with the overall surveillance of the stockpile and is required to advise the Secretary of Defense as to the technical status of the stockpile. One of the primary vehicles for accomplishing this function is through the conduct of technical inspections. Still in the area of technical services, the DESA has considerable responsibility in the field of weapons effects and tests. After obtaining the requirements for information on atomic weapons effects desired, the DESA, in coordination with the services and agencies concerned, prepares an integrated full-scale weapons effects test program. Preliminary plans for the military phases of such tests are then prepared, and recommendations are made to the JCS as to the composition and command or control of task forces to conduct the tests, or to support the AEC in conducting the DoD portions of tests. At the conclusion of the tests, DESA prepares reports and analyses of the results and provides within the DoD a central agency for the collection and dissemination of technical information as to the effects, characteristics, reliability, safety, and vulnerability of atomic weapons. In the field of research and development, DESA provides primary DoD liaison and guidance to the AEC in those matters not appropriate for the MLC, conducts feasibility studies, prepares and submits the service-desired military characteristics for AEC-developed weapons, reviews AEC designs to ensure compliance with these military characteristics, and participates in the coordination of the development effort on atomic weapons approved for development. As for logistical services, DESA is responsible for consolidating the requirements for and effecting procurement of AEC-produced training weapons, operational suitability test weapons, test and handling equipment, associated repair parts, and other AEC-produced material. Arranging with the AEC and the services for the orderly dispersal and distribution of atomic weapons and associated repair parts. Informing commanders and the services of the estimated availability of atomic weapons to fill allocations and of technical limitations affecting the operational use of atomic weapons. Operating those stockpile sites used primarily to store and maintain the JCS reserve. Providing centralized coordination among the services and with the AEC in planning and scheduling modifications, modernization, and quality assurance programs to ensure minimum loss of weapon availability. Furnishing guidance on environment and construction standards for the storage and maintenance of atomic weapons worldwide to ensure optimum security and safety consistent with operational demands. In connection with its training mission, DESA conducts orientation courses for key civilians and military officers in the military application of atomic energy. It trains future atomic staff officers in the characteristics and effects of atomic weapons and in the technical considerations essential to their successful employment against an enemy target. It conducts specialized training courses for personnel from the services in the assembly, handling, storage, and maintenance of atomic weapons. In summary, it can be said that by accumulating and disseminating specialized technical knowledge, assisting in the basic and detailed training of personnel, and by coordinating and providing for many of the development and logistic requirements, the Defense Atomic Support Agency fulfills its mission to the military services and fits in its place in the complex national effort. Thus prepared, when an atomic weapon is produced and ready, either for stockpile or for use against an enemy, we will be in readiness for any assignment, whatever or whenever it may be. A nuclear explosion is the instantaneous release of a tremendous amount of nuclear energy. A nuclear weapon is the instrument which brings about the release of this energy. Nuclear energy comes from two processes that alter the nuclei of atoms. One is fission, and the other is fusion. First, let us consider the principles of nuclear fission. When the nucleus of an atom of a fissionable element, such as uranium-235 or plutonium-239, is struck by a neutron, the atom splits, or fissions, into two or more parts. The combined weight, or more correctly, the mass of these fission fragments, is less than that of the original atom. The lost mass has been converted into and released as energy. During and as a part of the fission process, another reaction has also occurred. 2 or 3 neutrons have been released and may strike the nuclei of other fissionable atoms, and thus continue the fissioning process. Essentially, it is a continuation of this action that makes a fission reaction possible. Because stray neutrons are always present, there are limits to the amount of fissionable material that can be assembled without producing a premature reaction. If the amount or shape of the active material is such as to permit the neutrons given off by spontaneous fission to escape after only a few fissions, the nuclear reaction is not self-sustaining, and the condition of the mass is said to be subcritical. If the configuration and amount of active material is such that one neutron from each fission does not escape and goes on to fission a new atom, a continuous self-sustaining reaction known as a chain reaction is created, and the mass is said to be critical. The sun is constantly creating and releasing energy created through a fusion process. Fusion is the second process through which energy is liberated from the nuclei of atoms. The process of fusion is the reverse of fission. In fission, a nucleus of an atom of high atomic weight is broken up to form other elements. But in fusion, the nuclei of two lighter elements are combined to make a heavier element and to release a great amount of energy. Fusion in nuclear weapons utilizes two of the isotopes of hydrogen to release energy. They are deuterium and tritium. Fusion will occur when the nuclei of the two atoms are given enough energy so that they can penetrate the repulsive force surrounding the nuclei. When the nuclei of deuterium and tritium undergo fusion, a helium particle will be created and a high-energy neutron emitted. A total energy of 17 million electron volts is liberated in the process. In order to produce a fusion reaction, the conditions of high temperature and high pressures found in the interior of the sun must be duplicated.